So we're going to analyze our truss system right here using the method of joint, and we need to find the internal force for each of the members. So as a start, we always need to calculate our reaction force. So we have two reactions here, the support at R1 right there and the support at R2 right there. Now, to begin with, we need to first of all identify the distances that we have from our pivot point. So let's establish that we're going to take the moment about R1 right there. So the first force that we're going to look at is the 4 newtons there. And if we just set up our system that we're going to use, which is clockwise moment, will be equal to counterclockwise moment. And for our force, 4 newtons, that is 2 meters away from our pivot point. So if we just do force multiplied by perpendicular distance, so that gives us the first moment. And then let's go to the 3 newtons. So that's now going to be 4 meters away from R1. So that again is our force, 3 newtons, multiplied by the perpendicular distance of 4. And we go across then to the 5 newtons and its distance once again. So that's the 5 newtons. I'll just highlight this one so you can see. So that's that force path there, and it comes across all the way to the R1 pivot point. So for that one, it's going to be 5. So that's the force multiplied by perpendicular distance of 6. So now the only other force that we have that's rotating counterclockwise is R2, which is trying to do that. So this one will be R2 multiplied by the full length of 8 meters. So that's equal to 8 times R2. Now, all we have to do here is just to simplify our equations. So we have 4 times 2, so that gives us 8, plus 4 3s 12, plus 30 equals 8 times R2. So if we get to what R2 is equal to, it's just 30 plus 12, so 42 plus 8, so 50 divided by 8. So our answer for R2 is 6.25 newtons. So that represents R2. So for R1, we're going to say then that upward force, the sum of the upward forces, should be equal to the sum of the downward forces. So all we have going up will be R1 plus R2, and we have a few forces going downward, so that's the 4 plus 3 plus 5 newtons. And because we already know what R2 is, we can just sum these up and subtract our R2 value. So then that gives us R1 as 12 minus 6.25. So final answer for R1 is 5.75 newtons. So that's the reaction forces done, and we're now going to calculate the internal forces for each member. I usually don't ask because I hate to interrupt the lesson, but if you could subscribe to the channel if you haven't done so already, that would be wonderful. And if you could also give the video a thumbs up if you like it, then that would also be wonderful. So let's continue. So let's take this then to be joint 1, and we're going to assume that each of these members are going away from the joint until we find out what the actual answer is. So let's label this then as F1 for force and F2 for force. So force 1, force 2. And we already know what R1 is. R1 turned out to be 5.75 newtons. So with that, let's just calculate using again our force component method. Let's calculate the vertical and horizontal force components. So for vertical components, we're going to have that 5.75 newtons, that's going upward, plus we're going to have our F1 going upward, and the force component for our vertical direction is force sin angle. So it's going to be F1 sin 30 degrees. That equals 0. So it's very important to note that what we're going to do to calculate all our vertical, I'll just jot this down over here. So our vertical components, all of them will be force sin angle, and our horizontal components will just be same force but cos and the same angle. So let's calculate F1 now that we have our equation set out. F2 is not included simply because F2 is just an horizontal member, so there's no vertical component for F2. So then F1 sin 30 is equal to, if we do the inverse of plus 5.75, that will give us negative 5.75. So all we have to do is just divide that by sin 30 to get what F1 is. So negative 5.75 divided by sin 30 will give us F1, which turns out to be negative 11.5 newtons. So that right there is our F1, and to get F2 we're going to use the horizontal force components method. So for horizontal, I'll just put HC for horizontal components. We're going to have F2, which is just a purely horizontal member, no vertical components to that. So that's why it's just F2. So it would be F2 plus F1, that same F1 that we just found. And it's going to be cos 30 for the angle. And those are all the horizontal components, so all of that will be equal to 0. And it's equal to 0 because we're saying our system is in equilibrium. So solve for F2 now. So F2 would then be equal to minus F1 cos 30 if we were to simplify our equation, and then just input our value that we got for F1. So let's input our value now, and F2 would be equal to, so this is the minus for the inverse operation there, and then now the value of F1 was negative 11.5, that goes there, and times by cos 30. So our final answer then for F2 is 9.96 newtons. And it's positive, so that's a tensile member. And F1 was negative, so that was a compressive member. So that's joint 1 done, and we're going to go to joint 2 now to calculate the internal forces. So for joint 2, it's going to be the same principle we follow. So let's start by assuming that our arrows are pointing away from the joint, meaning they're all tensile members, and then when we get our answers, we'll prove whether or not they are. And for our force component, it's going to be once again force cos angle to get our horizontal component, and force sin angle to get our vertical force components. So it's the same convention we're going to use. So let's start with the vertical force components then. And for the vertical force components, this time around we have R2 that's going upward, and we're going to have, let's label this as F4 and this one as F3. So we're going to have F4 going upward, so plus F4 and the angle sin 30 equals 0. So then if we just substitute what we know for R2, which we just calculated, that R2 was 6.25. So let's do some substitutions now. So this was 6.25 for R2, so that will be added with F4 sin 30 equals 0. So for F4, we're just gonna do the inverse here, subtract our 6.25 and then divide by sin 30 to get F4. So F4 is equal to minus 6.25, so that's the inverse operation there, and then divided by sin 30. So final answer for F4 is negative 12.5, and that's negative, so therefore it's a compressive member. And then let's go over to the horizontal components now. So for the horizontal components, we have F3, that's horizontal, purely horizontal, plus we have the component for F4, so F4 cos angle, and all of that equals 0. That's all our components there for the horizontal bit. So let's do some substitutions and rearranging formula, and we should get F3. So if we rewrite this, F3 would then be equal to, so it's minus F4 cos 30. So that's just inverse operation there. Inverse of plus F4 cos 30 is minus F4 cos 30. So to substitute the values now, so this is minus, and then F4 value is negative 12.5 times by cos 30. So our final value then that we arrive at for F3 is 10.83. So this is a tensile member, F3 is. So F3, tensile member, F4, compressive member. And those are our force values. So let's move on to the next joint then. So once again, we're going to take our directions like that. All of the arrows pointing away from the joint itself. And this was our F1, so that member there was our F1 member, and we calculated F1 already, and we got negative 11.5 newtons for that. Now let's say this is F5 and this one is F6. Now this one, you will notice that there is going to be more than one unknown, so we're going to have to take a slightly different approach to this one. So what we do know, let's draw in, this is a referenced horizontal line, and the angle right here, all of this angle here is 60 degrees, but we're going to split it into two, so that's 30 degrees there and 30 degrees here. And of course, if we do vertically opposite angles, this here will be 30 degrees as well. So let's now start to put together our components, because this one will be slightly different. So just stay with me and you will get there. So we're saying that upward forces here should sum to give the same as downward forces. And what we have going upward is only this F6 member. That's the only arrow that's pointing upward. So we're going to write that in along with the angle. So this will be F6 sin 30. So that's what's going upward. What's going downward now will be our F1. So F1 and the angle sin 30 plus F5 sin 30 and plus that 4 newtons that's going downward. So that's the everything balanced. Now what I'm going to do here, I'm going to simplify this equation by just dividing through by sin 30. So when we divide through by sin 30, so each term there got a sin 30 except for the 4. But sin 30 is actually a numerical value. It's the same as a half. So when we do that, we simplify this now. So I'm just putting here that we're dividing through by sin 30. So what we have left here is just F6. That will be equal to just F1 plus just F5 plus, when we do 4 divided by sin 30, then we are going to get 8. But let's just put that in 4 over sin 30 for now. Okay. And if we were to just input now the known values, we have one known value here. We have f1. So we're going to just rewrite this now. So f6 equals our f1 value, which is negative 11.5 plus f5, and plus 4 divided by sin 30 will give us 8. Just before we do any substitution, we are going to have to first sort out our horizontal component. So let's do that. So this is now our horizontal force components bit that we're working through. So again, we're going to balance what's going to the left versus what's going to the right. So what's going to the left is F1. So if we say F1 cos 30, that's the only force that's going to the left. Everything else is going to the right. So for the next bit is F5 and cos 30, plus that with F6 and cos 30. So those are all the components going to the right. And if we do the same thing that we just did, we're going to divide through by cos 30 now. So all of these members we're going to divide through by cos 30, and that will just leave us with F1 equals F5 and plus F6. Now we already know what F1 is once again, so let's substitute that and we get negative 11.5 equals F5 plus F6. So what we do with this now, we can just make either F5 or F6 the subject and substitute that into our equation that we did up top here, right there. So that's exactly what we're going to do. So we're going to start by making, let's say, F6 the subject. So if we were to therefore make F6 the subject, then this is just going to be negative 11.5, and the inverse of plus F5 will just be minus F5. And we're going to substitute this bit now, this negative 11.5 minus F5 into this equation up top. So that's we get what F5 turns out to be. So let's do that now. So this was the original equation. So it was F6 equals negative 11.5 plus F5 and plus 8, and we're substituting the value that we have here, right here, for F6. So when we substitute, we end up with negative 11.5 minus F5 there, and that will be equal to negative 11.5 plus F5 and plus 8. So if we were to group the like terms here, we would end up with F5 plus F5, and that will be equal to negative 11.5 plus 11.5, that's inverse up, and minus 8. So that's grouping like terms now, and then this just leaves us with 2F5 equals negative 8. So as you can see, therefore now our F5 is equal to negative 4 newtons, which is compressive. So that's the value we get there for F5. And for F6, we're going to just use the simpler equation, which is this one right there that I've just pointed that arrow to. Let me change the arrow color. So that one right there, that's what we're going to use to work out what F6 is. So let's do that. So let's just rewrite the equation then. So F1 equals F5 plus F6. and we already know what F1 is, we already know what F5 is. So let's do the substitution then. So F6 would be equal to F1 minus F5. And these are the values for F1 and F5. So negative 11.5 for F1 minus F5, which is negative 4. So our final answer here for F6 is going to be negative 7.5 newtons. And these are two compressive members. So that's F5, F6 done. Let's move on to the next joint then. So for this joint, if we input again another referenced horizontal line like that, then we will have this member, this angle being 30 degrees, and this next angle being 30 degrees as well. Now this right here was our F6, and F6 was negative 7.5 newtons, and these two are our unknowns, right there and right there. So let's say this one is F7 and F8 right there. So again, we're going to resolve these using our same method. So let's say forces going to the left equals forces going to the right, and we're going to start with the horizontal components. So what's going to the left is F6, so we'll use F6 and cos 30, and what's going to the right is F8, so we'll say F8 and again cos 30 for our reference angle. So if we were to divide both sides here by cos 30, then what we have left is just F6 equals F8. And we already know what our F6 is. So therefore, F8 will be equal to F6. So F6 is equal to negative 7.5 kilonewtons. Likewise, F8 equals negative 7.5. I just wrote kilonewtons, but they're all in newtons. So that's F6 and that's F8. So the next one would be our F7. So let's work out our vertical force components. Now all of these are going downwards, so this should all sum to be 0. So our vertical force components now, so what we have going downwards are 3 newtons, plus now we will have F6 sin 30, plus this F7, that's purely vertical, so no horizontal component, plus F8 sin 30, and all of that will be equal to 0. So let's substitute all our known values then. So that would be, so 3 plus, we know F6 to be negative 7.5, so negative 7.5 for F6, multiplied by sin 30, which is 0.5, so 0.5, plus our unknown here, which is F7, plus F7, and plus we know what F8 is. F8 once again is negative 7.5, and times that by sin 30, which is 0.5, and all of that equals 0. So let's simplify this equation then, and we can say now that F7 will be equal to all of this minus 3, and I'm just going to write in these as the inverse as we go, plus 0.5 times 7.5, so notice that that's positive now, and plus 0.5 again times 7.5. So F7 final answer is 4.5 newtons. So that right there is a tensile member. Now we have one last joint to go, and for this last joint it's going to be exactly the same process that we follow. So let's go through it. So let's follow the same system here. So that's going to assume to be going away from the joint, but we already know the values anyways. So let's input, that was F8, and that will be equal to negative 7.5 newtons. This one was F4, which was negative 12.5 newtons. And this one is our last one, so that's F9. And in terms of our angles, once again, we're going to establish this dotted line here as our reference, and we input the angle here. So 30 degrees. This will be 30 and 30 degrees there. So let's work out what we're going to get now for F9. So let's establish our horizontal force components first. And what we have here, let's do what's going to the left. So that will be F8 and cos 30 plus our F9 and cos 30. And all of that should be equal to, so what's going to the right, let's balance that. So it should be F4 and cos 30. Now once again, because we have cos 30 in all of these terms, we can divide through by cos 30. So we're just left with F8 plus F9, and that equals F4. Now, if we substitute all our known values, then we're going to have F9 equals F4 minus F8, and putting in these values now. So F4 is negative 12.5. So F8, negative 7.5. And when we simplify all of this now to get what F9 is, that's just negative 5 newtons, and that's compressive. So that's all members solved using the method of joint. Now, if you'd like to check out the graphical method, then check either one of these videos out and they'll go through the graphical method step by step.